students, let us study the chapter 9 of chemistry today, elements of group 13, 14 and 15. In this chapter, you are going to study the elements of the group 13, 14 and 15 in some details. The elements boron, aluminium, gallium, indium and thallium constitute the group 13, called the boron family. The elements carbon, silicon, germanium, tin and lead form the group 14, called the carbon family. The elements nitrogen, phosphorus, arsenic, antimony and bismuth belong to group 15 of the periodic table, called the nitrogen family. In the table shows the condensed electronic configuration of the elements of group 13, 14 and 15. In the table, some physical and atomic properties of group 14 elements. Chemical properties of the elements of group 13, 14 and 15. Table nature of stable oxides of groups 13, 14 and 15 elements. Reactivity towards air, oxygen. First, group 13 elements. Elements of group 13 on heating with air or oxygen produce oxide of type E2O3, where E equals to element. Second, group 14 elements. The elements of group 14 on heating in air or oxygen form oxide of the type EO and EO2 in accordance with the stable oxidation state and availability of oxygen. Third, group 15 elements. The elements of group 15 on heating in air or oxygen form two types of oxides, E2O3 and E2O5. Allotrophy. When a solid element exists in different crystalline forms with different physical properties such as color, density, melting point, etc., the phenomenon is called allotrophy. Diamond, as shown in the figure. In diamond, each carbon atom is linked to 4 other carbon atoms. Uses. Diamond is used for cutting glass and in drilling tools, for making dyes, for drawing thin wires from metal, for making jewelry. Graphite. Graphite is composed of layers of two-dimensional sheets of carbon atoms. Fullerenes. Fullerences are allotropes of carbon in which carbon molecules are linked by a definite number of carbon atoms. For examples, as in C60. C60 has a shape like soccer ball and is called Buckminster's fullerene or buckyball, as shown in the figure. Carbon nanotubes. Carbon nanotubes are cylindrical in shape, consisting of rolled up graphite sheet, as shown in figure. It can be used to build lightweight spacecraft. Graphenes. Isolated layer of graphite is called graphene, as shown in the figure. Let us see the molecular structure of common compounds of elements of group 13, 14 and 15. Boron trichloride, that is BCl3. Aluminium chloride, that is AlCl3. Diborane, that is B2H6. Silicon dioxide, that is SiO2. Nitric acid, HNO3. Orthophosphoric acid or phosphoric acid, H3PO4. Let us see the properties and uses now. Borax. Properties. Borax is white crystalline solid. Borax dissolves in water and gives alkaline solution due to its hydrolysis. Uses of borax. It is used in the manufacture of optical and hard borosilicate glass, as a flux for soldering and welding, as a mild antiseptic in the preparation of medical soap. In qualitative analysis for borax bead test, as a brightener in washing powder. Silicones. Properties of silicones. They are water repellent. They have high thermal stability. They are good electrical insulators. They are resistant to oxidation and chemicals. Uses of silicones. They are used as insulating material for electrical appliances, waterproofing of fabrics, sealants, high temperature lubricants for mixing in paints and enamels. Ammonia. Properties. Physical properties. Ammonia is colorless gas with a pungent odor. It has freezing point of 198.4 Kelvin and boiling point of 239.7 Kelvin. It is highly soluble in water. Chemical properties. Ammonia reacts with acids to form ammonium salts. The aqueous solution of ammonia is basic in nature due to the formation of OH negative ions. Uses. Ammonia is used in the manufacture of fertilizers such as urea, diammonium phosphate, ammonium nitrate, ammonium sulfate, etc. Manufacture of some inorganic compounds like nitric acid, refrigerants, that is liquid ammonia, laboratory reagent in qualitative and quantitative analysis. That is all in this chapter. Thank you very much.